Hello, good evening, Andariki. Good evening, very good evening, all of you. Hi, hi, Maitri, hi, Darkens, Pandana, Parimala, very good evening, Abhi, hello, Abhi, hello. So, how are you all, Rick? How is the energy? Cheppandi Andari. Hi, Mysterious, hi. Hi, Shiva, right? Your name is Shiva. Hello, Isha. Hi. Hi, Geeta. So, how are you all, Rick? So, are we all in the state to start this new chapter? Cheppandi okasari. Good evening, Abhi. Good evening. Okay. Hey, how many of you are present? Good. Attendance is good, right? The chapter is easy, kada? Yes, sir. The chapter is good. So, our attention is good. Okay, Shiva, good. Right. So, let us start with a brilliant chapter, your Newton's laws of motion. Okay. Newton's laws of motion. NLM. Hey, good evening, Gitanjali. Good evening. Hi, Parimala. Good. Thank you so much, Parimala. Thank you so much. Chalo. Start. Let us start. I think we can start. Right. Hey. So, in chapter lo, we are going to start from the prerequisites. Prerequisites ante enti, sir? Prerequisites ante whatever we discussed. Okay. So, prerequisites ante what you require for this chapter. The first thing that you will be requiring is vectors. Hey, vectors is not good. Newton's laws will not be good. Okay. Vector ante very important. Very important topic. Okay. Chuskondi. So, start chedam andariki. So, what are the prerequisites, sir? Prerequisites ante vectors. Okay, for those who have missed the vectors lecture and those who don't want to go back again and see that lecture, let me quickly revisit vectors chapter. Okay, let me quickly go and revisit vectors chapter. Deentlo ma daggara 3 formula unnayi kada. Yes. So, we have 3 formulas. What are the 3 formulas? Cheppandi. Hey, cheppore andariki. Hello. So, sir, very thin, right? Very thin. Okay. And resultant of vectors kada. Why so thin, right? Okay, visible. I think it's visible to all of you. Yes. Hi, Himarati. Good evening. Chuddam. So, sir, resultant kosam angle kavale. Angle between the vectors we study in vectors. Okay, we study in vectors. And if 2 vectors are head to head or tail to tail, then and only then it will become angle. Leda, you shift the vectors. Shift chesi, you convert it into angle between the vectors. Very good evening, Joshna. Very good evening. Okay. Hi. Hello. Hi. Okay. So, resultant ante enti, sir? Ide na first vector. Peru A bar. Ide na second vector. Ekkadochi B bar. Renditlo angle is theta. Chappu. Sir, resultant of A bar plus B bar is equals to the root of magnitude. Cheppandi. A square plus B square plus 2 into A into B into cos theta. Ade kada? Ide kada? Chuskondi. Hey, you look. Hi, Vaishu. Hi. So, this is the formula for the resultant between the 2 vectors. Ante kada? Are you having any doubts? Good. Okay. Sir, what about subtraction, sir? Sir, mod of A bar minus B bar. ఫార్ములా చెప్పండి అందరికి. సో ఇట్ ఈస్ ఈక్వల్స్ టు a స్క్వేర్ ప్లస్ b స్క్వేర్ minus 2ab cos theta రా. theta అంటే యాంగిల్ బిట్వీన్ ద వెక్టర్స్, అదే. గుడ్ పరిమళ, వెరీ గుడ్ వెరీ గుడ్ వెరీ గుడ్. ఓకే గుడ్. సో దాని తర్వాత దాని తర్వాత వీఆర్ టాకింగ్ అబౌట్ రెజల్యూషన్ ఆఫ్ వెక్టర్స్ రా, అదే. రెజల్యూషన్ ఆఫ్ వెక్టర్స్ తొందరగా చెప్పండి అందరికి. వాట్ ఆర్ ద రెజల్యూషన్స్ అండ్ వాట్ ఆర్ ద కాంపోనెంట్స్? అరే చూసుకోరా. సో ఇదే నా మెయిన్ వెక్టర్స్ ఉంటే, సో దిస్ ఈస్ మై మెయిన్ వెక్టర్ ఏ బార్ రీ, చూసుకోండి. అండ్ ఐఎమ్ ట్రయింగ్ టు రిజాల్వ్ దిస్ వెక్టర్ ఇంటూ 2 different డైరెక్షన్స్. సో ఇదే నా ఫస్ట్ డైరెక్షన్, ఇదే నా సెకండ్ డైరెక్షన్, అంతే కదా. లెట్ us say this angle is theta అందరికి చెప్పండి ఒక్కసారి. Isha, you did not see the thumbnail, huh? Why are you not seeing the thumbnails, ra? Okay, so sir, components గురించి మాట్లాడితే సార్ ఇదే a cos theta and ఎక్కడ వచ్చి this vector will be a sin theta, అంతే కదా. ఎస్ రే 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 చాలా ఇంపార్టెంట్ ఇది. ఇట్ ఈస్ వెరీ ఇంపార్టెంట్. ఓకే ఓకే. సో దిస్ ఈస్ very important from Newton's laws point of view. Okay, so if you don't have the grip over this, then you will not have the grip over Newton's laws of motion. Good ray, చూసుకోండి. So let us solve a question, right, based on it. So I have tried to keep as much things as possible into this chapter. Okay, చూసుకోండి. So an object of mass 10 kg acted upon 3 forces, ray, as shown in the figure. The net acceleration of particle. Figure ekkada sir? Figure is here. Okay, figure is here. Okay, I'll give you. So idena block. Hey, mass 10 kg ray. Mass 10 kg kada? Yes, mass 10 kg. I am taking general values. Okay, general values ra. So let us say this is 100 Newton. Ide angle is 60 degrees. ekkada vachi this is the second force ra. Idi kuda 100 Newton తీసుకోండి. And ekkada kuda angle you take it as same 60 degrees ra. చెప్పండి. And here you take the third force. Okay, how much will you take? Will you take 20 Newtons force? చెప్పండి. Not 20 రే, 10 only ra, 10 only. ఎలా సాల్వ్ చేయాలి? How? Hi Raju, hi. ఓకే, సో చెప్పండి అందరికి. రెజల్యూషన్ ఆఫ్ ద వెక్టర్స్. గుడ్ ఈవినింగ్. ఓకే చలో. సో ద ఫస్ట్ కాంపోనెంట్ ఆఫ్ దిస్ వెక్టర్ విల్ బి టువర్డ్స్ ద రైట్ సైడ్. ఈ ఫోర్స్ కోసం కూడా ద కాంపోనెంట్ విల్ బి ఇన్ ద రైట్ సైడ్. చెప్పండి రే అబౌట్ ద అదర్ వెక్టర్. సో సార్ ఇట్ విల్ బి డౌన్వర్డ్స్, సార్ ఇట్ విల్ బి అప్వర్డ్స్, అంతే కదా. ఎస్, వాల్యూస్ చెప్పురా, వాల్యూస్ చెప్పు. హాయ్ గుడ్ పరిమళ, వెరీ గుడ్. సో 160 అంటే 100 into cos 60 రా, అంతే కదా. సో 100 cos 60 ఇక్కడ కూడా, అండ్ హియర్ ఆల్సో 100 into cos 60 రే, అండ్ automatically it will become 100 into sin 60, అంతే కదా. ఎస్, హియర్ sir it will also become 100 into sin 60. What about this రే? What about this? It will not get resolved ఎందుకంటే it is already in the horizontal, sir. We cannot resolve into perpendicular directions, అంతే కదా. హాయ్, గుడ్ ఈవినింగ్ అనిత. గుడ్ ఈవినింగ్. చూసుకోండి రే. సో నా సార్ 100 cos 60 is 1/2. 1/2 into 100 అంటే 50. ఎక్కడ కూడా 1/2 into 100 అంటే 50. రైట్ సైడ్ లో రే, ఇన్ ద హారిజంటల్. చెప్పోరా అందరికి. ఇన్ హారిజంటల్ చెప్పండి. ఇన్ హారిజంటల్ డైరెక్షన్ రైట్ లో నెట్ ఫోర్స్ అంటే 50 + 50 అంటే 100. ఎక్కడ కూడా అరే చాలా మిస్టేక్ అయిందిరా. ఇట్ షుడ్ బి 100, నాట్ 10. It should be 100. Okay, adjust it. So this is 50 అంటే 100. Okay, yeah. What Josna, what do you want to use for this question? Good. And here also 100. So sir 100 becomes 0, gone. No vector in the horizontal. And net force is 0 re. net force is equals to 100 minus 100 is equals to 0. Okay, vertical lo cheppandi ra. Vertical motion. 100 sin 60 కదా అంటే 100 into root 3 by 2. ఎక్కడ చెప్పండి 100 into sin 60 అంటే 100 into root 3 by 2. 50 root 3 here also చెప్పండి 50 root 3 అంతే కదా. సో vertical లో also the forces are equal and opposite sir. So అంటే net force is equals to 50 root 3 in the upper direction. ఇది 50 root 3 in the lower direction అంటే net force in vertical is also 0. Horizontal లో కూడా net force is 0 అంటే net force acting on the object becomes 0. Force 0 అయితే acceleration కూడా 0 అవుతుంది. Good. 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 Next. Next రా చూసుకోండి. A ball of mass 5 kg placed at one of the vertex of a square రా. And 3 forces are acting on the ball along the remaining vertices. Each force is 20 Newton. The acceleration of the particle is what? Cheppandi. So, ide na square kada? Yes. Oh, sir, on one end, you are putting the ball, right? Hey, pettandi. Mari cheppandi. Bolo, bolo. Kamosh mat baito, bolo. Hey, ఇది నా ఫస్ట్ ఫోర్స్, దిస్ ఇస్ మై సెకండ్ ఫోర్స్, దిస్ ఇస్ మై థర్డ్ ఫోర్స్ అంతే కదా. ఆల్ ఆర్ ఈక్వల్ టు 20 న్యూటన్స్ రే. ఆల్ ఆర్ ఈక్వల్ టు 20 అంటే ఇది కూడా 20 న్యూటన్, ఎక్కడ కూడా 20 న్యూటన్ అండ్ హియర్ ఆల్సో 20 న్యూటన్ ఫోర్స్. 3 ఫోర్సెస్ 20 న్యూటన్ ఈచ్. హౌ విల్ ఐ యాడ్ సార్? సార్ 20 plus 20 plus 20 becomes 60 అంతే కదా. సో నెట్ ఫోర్స్ ఇస్ హౌ మచ్ రా చెప్పండి. నెట్ ఫోర్స్ ఎంత వచ్చింది రా? So sir, net force is equals to 60 Newton. Ante kada? Yes. Mass enta ra? 5 kg. So sir, acceleration is equals to force by mass ante 60 by 5 ante 12 meter per second squared. Got it? Got it? Got it? Wrong. 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 Hey, that's wrong re. It's wrong re. It's wrong. Endukare? Force is not a scalar quantity. You cannot simply add it. Vectors law, we have broken our head in explaining the concepts. And these people who are agreeing, they are saying it's okay. Okay, we don't care. We simply don't care, sir. Whatever you do. ఏదైనా చేయండి కానీ we don't care. Okay, Gonad, you said no. So how will I do it? So for that, మొదటిగా I will consider these two forces రా. చెప్పు అంటే ఇది ఫోర్స్ ఇన్ ద హారిజంటల్ వాల్యూ అయితే 20 న్యూటన్స్. ఎక్కడ కూడా చెప్పండి అందరికి ఇది ఫోర్స్ అంటే 20 న్యూటన్. ఫస్ట్ యాడ్ దీస్ టూ రా. యాంగిల్ ఎంత రా బిట్వీన్ ద ఫోర్సెస్? వాట్ ఈస్ ద యాంగిల్ బిట్వీన్ ద ఫోర్సెస్ చెప్పండి అందరికి? 90 degrees. 90 degrees. 90 degrees. So sir, here is 90 degree angle. Okay. So sir, V net is equals to directly root of 20 square plus 20 square. Plus 2ab cos theta కూడా రాయొచ్చు కానీ యాంగిల్ is 90 degree రా. So there is no use of writing it. Okay. అంతే కదా. You simply say sir it is equals to 20 root 2 newtons. Direction రే. Direction చెప్పు రా. 20 root 2 newtons రా. Direction sir between the forces. ఎక్కడ between the forces రే? Where between the forces రే? Forces అంటే exactly in the middle రే. Exactly the direction of this 20 Newton force. అంతే కదా. So this is my 20 root 2 Newton force రా. చూసుకోండి. So net force అయితే net force is equals to 20 root 2 plus 20. 40 root 2 కదా. 40 root 2. 40 root 2. 40 root 2 right? Yes. Not 40 root 2. You cannot add it. Okay, you cannot add it. You can simply say sir 20 into root 2 plus 1 అంతే. సో ఇదే నా నెట్ ఫోర్స్ రా. యాక్సిలరేషన్ కావాలి రా చెప్పండి. యాక్సిలరేషన్ సార్ F is equals to ma సార్. ఫోర్స్ ఈజ్ మై మాస్ సార్, మై మదర్. సో ఇక్కడ నుంచి యాక్సిలరేషన్ ఈజ్ ఫోర్స్ బై మాస్ అంతే కదా. చెప్పండి రా. సో 20 into root 2 plus 1 divided by 5 అంటే 4 into in bracket root 2 plus 1 అదే మీటర్ పర్ సెకండ్ స్క్వేర్ రాసుకోండి. ఓకే నెక్స్ట్ నెక్స్ట్ ఈక్వేషన్స్ ఆఫ్ మోషన్ రా. సో ఏం ఈక్వేషన్స్ కావాలి రే, ఏం ఈక్వేషన్స్ కావాలి సార్? v is equals to u plus et, సార్ s is equals to ut plus half at squared, సార్ v square is equals to u square plus 2us. అదే గుడ్, మిస్టీరియస్, వెరీ గుడ్, వెరీ గుడ్, వెరీ గుడ్, వెరీ గుడ్. ఈక్వేషన్ ఆఫ్ మోషన్, v is equals to u plus at. It is the third time I am writing రే. It is the third time I am writing this on board. First time when we studied kinematics 1D, second time yesterday only ray, yesterday only, third time is today only. Okay, but I want you to understand the applications, not only the formulas. Good. Rendu the formula ray, sir. S is equals to ut plus half at squared. Antara, third one ray, third one, v square is equals to u square plus 2as. Ante kada. Sir, what is a, sir? What is a, sir? Acceleration. What is v, sir? Alphabet, sir. English alphabet, sir. English alphabet. Good. చూసుకోండి. Hey, this will be asked in a very different way in Newton's laws of motion. అంతే కదా. A block of mass 2 kg placed on another block of length 32 meters at one end. If there is a force of 88 Newton applied, how long it takes to reach the other end? Ante this is my another block. చూసుకోండి, this is my first block. అంతే కదా. what is the mass రే? 2 kg. sir, mass is 2 kg. length గురించి చెప్పోరా? length given కదా. yes, 32 meters. అంటే the length of this block is 32 meters రా, and a force of 8 Newton is applied రా. అంతే. now it is asking the time. ఎలా ఫైండ్ చేయాలి రా? ఎలా క్యాల్కులేట్ చేయాలి చెప్పండి అందరికి. టైం కావాలి, టైం, టైం, టైము రే, టైము రే. సింప్లీ సే distance is equals to initial speed 0 తీసుకోండి. Hey, all of you listen. In 90% problems in Newton's laws of motion, where we deal with acceleration type of questions ra, they give you initial speed is equals to 0. Okay, they don't want headache, you also don't want headache. Ante kada. yes, so initial speed 0 తీసుకోండి. so sir, s is equals to ut plus half at squared. u value 0 ra, ante it is gone. so s substitute చేసుకోరా. so s ante 32 meters is equals to half into acceleration ఎంత రే? sir, 8/2 force by mass ante 4 into t squared. so ekkadi nunchi send it there. directly I am writing t is equals to 4 seconds. okay, your calculation should be good enough. next, okay, Lami's theorem ra, it is also very important thing. okay, Lami's theorem is also required. చూసుకోండి, if your basics are good, your chapter will be good. if your basic is not good, your chapter will not be good. అంతే కదా. yes, so Lami's theorem ఏంటి సార్? Lami's theorem is only applicable, conditions గుర్తుపెట్టుకోండి. conditions రా. hey, మొదటి కండిషన్ రా. what is first condition, sir? first condition is the objects or the system should be in equilibrium. అదే ఈక్విలిబ్రియం అంటే ఏంటి సార్? అంటే నో మోషన్. ఓకే, సెకండ్ థింగ్, దెర్ మస్ట్ బి ఆడ్ నెంబర్ ఆఫ్ వెక్టర్స్ రా. అంతే. సో ఇఫ్ యూ హ్యావ్ దీస్ టూ కండిషన్స్, co-initial కదా. yes, so if you have these two conditions, ante you can apply Lami's theorem. తీసుకోండి. Lami's theorem, what does it say re? so if this is my object at equilibrium, it is by first force F1 force. in this chapter I am specifically saying force, okay, not vectors anymore. okay, so let us say this is my force F2 ra, and here is my force F3. theta 3, ఇక్కడ theta 2, and here is theta 1. చెప్పండి. so Lami's theorem simply says F1 by sine of theta 1 is equals to F2 by sine of theta 2 is equals to F3 by sine of theta 3. అంతే కదా. yes, so this is required రే. this is required. తీసుకోండి. this is a question. okay, the chapter has actually not been started రే. the chapter is actually not started yet, but still you can see the questions kada. Yes, not equal forces, go not equal forces, not equal forces. The object must be balanced. Teeskondi. Block is held in equilibrium with the help of three forces making angles 90, 150, 120 degrees with each other. Find the remaining forces. Ante ide na block re. Let us say 10 kg, okay? Let us say 10 kg. Sir, first force is making 90 degree ante let us say it is my F1 force. This is my F2 force and okay, so this is my F3 force ra. So let us do one thing, let us join all these forces at one point. Okay, so something like this ra. So this is my F3 force. Ante ide 90, ikkada 120 degrees and here ikkada vachi it is making 150 degrees. Ante kada. So it is making 150 degrees ra. F3 ki value teeskondi andariki. So F3 I am giving you as 100 Newton ra. Cheppandi. Remaining forces ante F1, F2 kavali. Calculate cheyandi andariki. Okay. I seriously don't understand one thing, okay? Some student is having some other name, he is telling, hello sir, my name is Shiva, and then another coming, sir, hello, my name is Honey, my name is Honey and my name is Chili, okay? My name is Lemon, sir, my name is Salt. Okay, I'll write the values, okay? తీసుకోండి. వచ్చిందా? అయిపోయిందా కదా? కేశవ నారాయణ. No, problems are important. Venkata Karthik. Without problems, you will not understand physics. Huh? I'll explain, all gone, everything gone. In exam hall, problems will be asked. Okay. Yes. So, cheppandi. Direct opposite angles తీసుకోండి రా. Opposite angles రా. So, sir, F3 by sin 90. అంతే కదా? Sir, F3 divided by sin 90 is equals to, చెప్పండి, F2 by sin 150. Sir, F2 divided by sin of 150 is equals to F1 by sin 120. అదేరా. F3 వాల్యూ ఎంతిరా? 100 divided by sin 91 అంతే కదా? చెప్పు. F2 by sin 150 రే. అంటే half is equals to F1 by sin 120 kada, root 3 by 2. So F2 is equals to 100 into half and F3 is 100 into root 3 by 2. Sir, ela chesindi. Gone 50 root 3 ante kada. Ratio ra. Ratio. Okay. Ratio. Good. Next. Hey. Now we are entering into the chapter. Okay. Now we are officially entering into the chapter. Chuskondi andariki. Very good. Mysterious. Very good. So frames of references. Ante I can say this is the beginning of the chapter also. And this is the ending of the chapter also. Hi Nandini. Very good evening. Why are you so late today? Okay. Frames of reference ante this is the beginning of the chapter also and this is the ending of the chapter also. Endukante okay, good. Hey, frame of reference ante enti ra? Sir, why are you confusing with our name, sir? Maaku andar good evening queen, good evening. Hi. Okay, sir, what is frame of reference? Why are you confusing us, sir? Hey, frame of reference ante your eyes, what they are seeing. Okay, so oka camera teesi footage teeskondira, so whatever you see in that footage will be named as frame of reference. Ante point of view ra, point of view. Okay, point of view, very good Gonat, very good point of view. You can say point of view, kani point of view ante it's not in the philosophical way. My point of view is all the politicians should be banned. This is not a frame of reference. Understanding? Frame of reference ante enti? Point of view. Yes, point of view. But what point of view, sir? Sir, in my point of view, poverty should be gone from India. That is point of view. That is frame of reference in physics. No. Okay, no. Point of view ante whatever you are seeing. Okay, you are seeing. Oka camera teeskondi. In that, whatever you see. Okay. Yes, point of view ante physical point of view ra, whatever you are seeing, it is known as point of view. So for example, you observe eyes. Okay, eyes of a person is frame of reference ra. Chuskodi. Eyes of a person, lens of a camera. Okay, yes. Point of view ante for an observer there will be the eyes or the camera. Yedaina teeskochu. Yes, exactly. Gonat. Yes. So you can imagine, okay, imagine చేసుకోండి అందరికి point of frame of reference ra. Frame of reference ante it is simply the observer. Okay, observer ante observer's eyes ante kada. Yes, so we do have two different types of frames of reference. Sir, why two, sir? Why not three, sir? ఎందుకంటే it could be divided into 3, 4, 5, 6 ఏదైనా తీసుకోవచ్చు. But the physics changes in two forms only. All the laws, all the nature, it changes only in two ways. కాబట్టి మా దగ్గర రెండు frames of reference ఉన్నాయి. Okay, good. So sir, inertial frame of reference ante entira? Inertial frame of reference is a frame of reference in which the eyes or the camera is either at rest లేదా ఒక కాన్స్టెంట్ స్పీడ్ తోనే మూవ్ చేస్తున్నారు. అండర్స్టాండింగ్? ఓకే, సో సార్ ఇనర్షియల్ ఫ్రేమ్ ఆఫ్ రెఫరెన్స్ అంటే observer is either at rest or observer is moving at not motion, uniform speed ra. Okay, terminologies అర్థం చేసుకోండి. inertial frame of reference అంటే ఏంటిరా అంటే observer, frame of reference అంటే observer or eyes ra. Okay, observer or eyes చూసుకోండి. It should either be at rest. Okay, it should either be at rest or uniform speed. అదే లేదా if the observer is having some accelerations. Okay, good. Chalo. So if the observer is moving with some acceleration, ఎప్పుడు it does not matter. చూసుకోండి అందరికి, acceleration constant, not constant, matter, it does not matter at all. Okay, it does not matter if the acceleration is constant or not constant. అంతే కదా? Okay, good. So sir, inertial frame అంటే ఏంటిరా? Inertial frame అంటే frame of reference, దీంట్లో observer is at rest or moves at a constant velocity. చూసుకోండి. ఇట్స్ అ వెరీ hairline difference రా. ఓకే, వెరీ hairline difference. ఓకే, okay, you understand. Okay, rest or constant velocity, only two factors ra. Don't disturb me, right? Okay. చూసుకోండి. So this guy is waiting at a waiting room. Okay, waiting room, rest. He is at rest, observing the aeroplanes. Can you see it? Hey, aeroplane is there. Okay. So ante whatever he is seeing will come under inertial frame of reference. Okay, yes. So whatever he is seeing will be considered his point of view. Okay, his motion will be considered as inertial frame of reference. Very important thing. Very important thing. What? Newton's laws are valid only in inertial frame of reference. Ante. Okay. Hey, focus here. Okay, focus here. So inertial frame of reference ante, that is my only target. All the Newton's 3 laws, we will be seeing 3 laws ippudu. We will be seeing 3 laws ra. Mottam laws are only valid in inertial frame of reference. Ante, sir, when you are doing the observation, you must be at rest or you must be moving at a constant speed. Ade, are you understanding? Then and only then, yes, go not, yes. Then and only then you will find that all 3 laws of Newton are valid. I will tell you. Okay, one by one we will take the frames of reference story also ra. Okay, next. తీసుకోండి. నాన్ ఇనర్షియల్ అంటే ఏంటిరా? నాన్ ఇనర్షియల్ ఫ్రేమ్ ఆఫ్ రిఫరెన్స్ అంటే, the definition was here. I think I forgot it. I think I forgot to add the definition ra. చూసుకోండి. నాన్ ఇనర్షియల్, అరే నాన్ ఇనర్షియల్ frame of reference is the one that ade, very simple definition. Okay, very simple definition. Okay. అంటే ఏంటిరా? Now that does not matter if the acceleration is constant or acceleration is variable. Similarly, చూసుకోండిరా, circular motion లో కూడా whenever you see an object, circular motion లో there is always an acceleration, అంతే కదా? So a circular frame of reference or a rotating frame of reference, not circular, a rotating frame of reference is always non-inertial. Okay, గుర్తుపెట్టుకోండి అందరికి, ఆల్వేస్ నాన్ ఇనర్షియల్. డైరెక్ట్లీ క్వశ్చన్ అడిగితే ఏం చూస్తారు? ఇఫ్ ఇట్ ఆస్క్స్ రొటేటింగ్ ఫ్రేమ్ ఆఫ్ రెఫరెన్స్ ఇస్ ఇనర్షియల్ ఆర్ నాన్ ఇనర్షియల్, వెరీ అండర్స్టాండింగ్. ఎందుకంటే రొటేటింగ్ ఫ్రేమ్ ఆఫ్ రెఫరెన్స్ అంటే సెంట్రిపిటల్ ఫోర్స్ ఉంటుంది కదా, సెంట్రిపిటల్ ఫోర్స్ ఉంటే సెంట్రిపిటల్ యాక్సిలరేషన్ కూడా there. So if centripetal acceleration is there, it's not a inertial frame anymore. Okay, next. Okay, forces గురించి మాట్లాడతాం రా, చూసుకోండి. So I have placed my heart into this chapter. Okay, ఎందుకంటే I'm explaining everything from a very scratch. Okay, from very basic level రా, చూసుకోండి అందరికి. 4 fundamental forces are there. Hey, చూసుకోండి. 4 fundamental forces ఉన్నాయిరా. ఓకే, గుడ్. Yes, Gunnar, you have to use equation of motion for uniform acceleration. Okay, chalo. So now come here. Strong nuclear, weak nuclear, electromagnetic, gravitation. Ade only 4 fundamental forces. Sir, but gravitation force naku telusa. 2 particles unte the force between them g(m1 m2 by r square) is gravitational force. Ante kada? Okay. What about friction? What about tension? What about string force? What about spring force? What about electric force, sir? What about magnetic force, sir? How will you classify them? Huh? How will you classify those forces, ra? Cheppandi andariki. I don't know what's happening to me today, but Cheppandi. So, sir, you remember this, okay? Just remember this. Epadaina strong nuclear force ante the force is the strongest amongst all force. All four among all four, strong nuclear is the strongest force. It holds the nucleus of an atom together. You visualize, okay? You understand it. How strong a strong nuclear force is. Hiroshima, Nagasaki. Hey, gurtunda? Huh? Okay. So they have broken the bomb, kada? Yes. So all that energy, when the nucleus was at steady position and entira, radioactive decay and all these things. Should I explain this or not? Let it be there. Focus on this. Ante the force required to hold the nucleus of an atom together is known as strong nuclear force. It's a very classic category. Ante. Are you understanding what is strong nuclear force? Strong nuclear, yeah, based on strength. Yes. So strong nuclear force ante, this is the force that is holding the nucleus. Very strong. Okay. To break a nucleus, you need immense amount of energy. Good. Nuclear force, you can say that. Okay. Similarly, weak nuclear force ante entira, whenever there is radiation, okay, radioactive decay, it is caused by weak nuclear forces. For now, just remember this, okay? Just remember, we will discuss all these forces in detail when we will be moving to those chapters, okay? 1945, not 1945, it's 1918, World War II, okay? Gravitational force ante మీ అందరికీ తెలుసా కదా? Gravitational force between sun and moon, long distance force, but it is very weak. Okay, strongest force ide, weakest force ide. Remaining all the forces are electromagnetic. Sir, I am pushing my hand with hand, sir. What force is it, sir? Electromagnetic. Sir, I am lifting this pen, sir. What force will you categorize? Electromagnetic. Sir, tension is there, sir. What force? Electromagnetic. Friction is there? Electromagnetic. Spring force, electromagnetic. Are you understanding? Okay. Electromagnetic includes between electric and magnetic forces. And whenever you have, okay, yes. So whenever you have atoms and protons, electrons involved into the interaction, force we will call it as electromagnetic force. Ante kada, 4 fundamental forces only. Hey, always remember, okay? Always remember. Fundamental forces only 2. No, Nandini, I am not ignoring the message. Okay, chalo, good. So now we have to study the exact forces, exact forces. Tension force, electromagnetic only, okay? Electromagnetic only, but we have to discuss about it. So we have to discuss about this force in detail. I am not getting anything to explain, okay? Okay, good. Cheppandi. Okay. So tension force. ఎప్పుడైనా గుర్తుపెట్టుకోండి, టెన్షన్ ఫోర్స్ ఆల్వేస్ యాక్ట్స్ అక్రాస్ అ స్ట్రింగ్ స్ట్రింగ్ సార్ స్ట్రింగ్ మీకోసం ఎస్ ఓన్లీ ఫర్ స్ట్రింగ్ అండర్స్టాండింగ్. యాక్చువల్లీ టెన్షన్ ఫోర్స్ కెన్ ఆల్సో యాక్ట్ అలాంగ్ అ చైన్, అలాంగ్ అ రోప్, అలాంగ్ అ రాడ్, అండర్స్టాండింగ్. బట్ వీ విల్ డిస్కస్ ఇట్ లేటర్ ఆన్. ఫర్ దిస్ చాప్టర్ కీప్ ద డొమైన్ limited to this chapter and you understand tension ante entira. Tension ante entira. No, Ritik, we can't do that, right? We can't do that. If you do that, then I'll be gone. Okay, I also want to jump to PYQs very eagerly, but limitations unnai. Good, exactly. Chalo. సో ఎప్పుడైనా టెన్షన్ ఫోర్స్ గురించి మాట్లాడితే ఒకటే గుర్తుపెట్టుకోండి, ఇట్ ఆల్వేస్ యాక్ట్స్ అలాంగ్ అ మాస్లెస్ ఇన్ఎక్స్టెన్సిబుల్ స్ట్రింగ్ రా. బోత్ వర్డ్స్ ఆర్ దేర్, రెండు టర్మినాలజీస్, మాస్లెస్, ఇన్ఎక్స్టెన్సిబుల్. ఇఫ్ యూ ఇగ్నోర్ ఎనీ ఆఫ్ దిస్, యువర్ మొత్తం బ్రెయిన్ విల్ బి గోన్ రే. ఓకే, ఎవ్రీథింగ్ విల్ బి గోన్. Point number 1, string should be massless. Good, very good. Go not, very good. And second thing, string should be inextensible. So if the string is inextensible, extensible string unte, this will be gone. Hooke's law will be valid. Hooke's law. Okay, we will discuss it. Chalo. So imagine, I will ask you one question. Okay, imagine tug of war. Okay, so this tug of war game, I want two people. Okay, I want two people. One is let us say Nandini and one is Spandana. Okay, good. So let us say this is Nandini, this is Spandana, because I seen two people only, I have taken the names. Chuskondi. Let us start this experiment. Okay, Nandini is pulling this string by a force of 100 Newton. Cheppandi. And Spandana is also pulling this string by a force of 100 Newton. One thing for sure, nobody will win the race. Ante kada? Nobody will win the race. So sir, what is the tension in the string in this scenario ra? Cheppandi. Ee moment lo tension enta ra string lo? Sir, how much tension? How much tension? How much tension, sir? 100 ekkada, 100 ekkada. Ante these two will get added and tension will become 200. I'll give you the option. Okay, tension enta ra string lo? Option A, opposite forces ante 0 Newton. Option B ante 200 Newton. Option C ra 100 Newton. And option D ra average of the forces ante 150 Newton. Cheppandi andariki, what is the tension in the string? What is the tension in the string ray if the two people are pulling this string in the opposite directions? Cheppandi. 200, darken, very good. So darken, answer is 200 Newtons. Cheppandi andariki. Tension force also 0. Okay, 0 I got it. Okay, so 200, 0 I got it. Cheppo andariki, cheppo. Go not, you are there. Constant. A ante 0. Okay. A, B, C, D nunchi cheppora. A, B, C, D ra. Okay. So 2 words for 0. Okay, 2 words for 0, 1 word for 200. Ante kada? Tension always added, darken. Good. Tension always added, so the tension will become 200 Newton. Okay. But both the answers are wrong. Right. What? 100. How come, sir? What is happening, ra? What is happening, ra? Chuskondi. I will tell you. Okay, I will tell you. Okay, let us add one more slide. So this, ఎవరైనా అల్లు అర్జున్ ఫ్యాన్ ఉన్నారా క్లాస్లో? Forgive me, okay? I did not draw good sketch. Forgive me. So this is our Allu Arjun, okay? Leda, sir, how dare you draw a person and call him Allu Arjun? No, experiment basis only, okay? So what he is doing, he killed the villains, okay? He beat the villains. Sarai Nudu picture, okay? Sarai Nudu picture. That low, he is pulling this chain, something like this, okay? He is pulling this chain to kill the people, right? Don't worry. We'll love Newton, okay? We will love Newton. No problem, okay? No, go not. 0 becomes 0 means the rope does not break, okay? Okay. So this is the rope, not rope. This is the chain, chain. So Allu Arjun is bringing this chain like this. He wants to kill the person, okay? How dare you do the corruption? Good. Hi, Prissy, hi. So when Allu Arjun is applying a force of 10 Newton, Chappora, what is the tension generated in the string? Okay, Balayya. Okay, let us take Balayya. Hey, Balayya. Okay, so this is Balayya. Sir, physics and Balayya, can they work together? Huh? Can they work together? No. Okay. 10 Newton. Tension in the string is 10 Newton. Ante kada. Tension is also how much? Hey, naku kavali ra acceleration, tension value. So I'll write options ra. Number 1, 10 Newton. Option number B, number 2, 0 Newton. Option C, sir, let us take the average and take 5 Newton. And option number D, sir, here is 10. Let us say the option is 20 Newton. Cheppandi andariki. Cheppo. How much is the tension in the string ra? 10 only. You won't consider physics, right? I will apply 10 Newton force. Balayya, what will say? What he will say? Let's not joke. Okay? He is my favorite actor actually. You know, he is my favorite actor. Kani, he is telling, hey, I have 5 kg mass. I apply 100 Newton force. On acceleration also 100. Acceleration also 100. Only magic, sir. So the tension in the string is 0 Newton, right? 0 Newton. Sir, why are you confusing us so much, sir? Why are you confusing us so much, sir? Why are you confusing so much? I'll tell you shortcut. Okay, I will tell you shortcut. After this shortcut tarvata, your all doubts will be gone. Okay, gone. So eppadaina tension ki value adigite chuskondi. So this is the first person, right? And this is the second person. Ante kada? Okay. So this is the rope. Hey, he is applying 60 Newton ra. And he is applying 100 Newton. Cheppo, what is tension now? Tension calculate cheyadaniki. Okay? Tension calculate cheyadaniki. Always remember, you see the string and the two ends ra. Two ends of the string. Okay? Two ends of the string. Okay. So take the two ends of the string ra, and whichever is having less force, not 160 re baba, not 160, whichever is having less force, here 100, here 60. Hey, which is less re? Which is less? 60. Ante the tension will always become 60. Understanding? Ardhamainda? Always the low force, less force becomes tension. Always the less force becomes tension. Okay? Ekkada kuda chuskondira. Here Balayya garu was pulling with 10 Newton force. Kani on the other side there was no force. No force ante 0. And always the low value is the tension in the string. Ante kada? Always the low value ra. Low value. Ekkada force is 0 ra. Chuskondi. No force at all. Only Balayya garu is pulling this chain. Okay? Good. So ekkada vachi one side force is 0, nobody is pulling the string. One side force is 10 Newton. Kabatti low side will always become tension. Until 0 Newton will be the tension in the string. Ante kada? Ade. What if the both forces are equal, right? So what if both forces are equal? So this is Balayya garu. And who should I take? Who should I take? Who is the competitor for Balayya? Who is the competitor for Balayya? Okay. So whatever it may be. Okay. So let us say, not 0 degree. Tension is not calculated in 0 degrees. Okay. Chuskondi. And let us say this person is A, some random person A. Okay. So if both are applying 100 Newton, right? Ikkada kuda the force is 100. Here also the force is 100 Newton. Cheppandi. Now tell me. Less side will be the tension, but both are equal. Yes, if both are equal, take any one of them. Both are equal kada ante. So if tension is equals to 100 Newton. Finished. Gone. Ippudu whatever I'll tell you, you will easily be able to tell me. Okay, chuskondira. Tell me the tension in the string. Here 120, here 100. Cheppandi andariki. What is the tension in the string? What is the tension in the string? Good, darken, very good, 100 Newton. Amazing. So tension is equals to 100 Newton. Ante kada? Always remember, if the two ends are having opposite forces, low side will be the tension. Okay, good, very good, very good, very good. So let us see re. Now I will give you one question. Choose kondi. So idena string ante kada? Are direction re. Hey, direction re. Direction is remaining. Good, very good. Kesava Narayana. How you can say 220 Kesava Narayana? You are not listening to the lectures, right? I have explained you 5 times. Re. Whenever two different strings are there, low will be the tension. Again you are doing the same thing. Ante, bring me a knife. I will kill myself. Okay? 100. Good, go not very good. So ఇప్పుడు డైరెక్షన్ గురించి చూద్దాం రా, చూసుకోండి. డైరెక్షన్ ఏంటి సార్? అంతే, always away from point. ఏం point sir? What point are you talking about sir? Huh? What point are you talking about? Whatever point you are interested ra. Okay, whatever point you are interested. Ante ide na string ra, and let us say this is the first person. This is Balaya and this is me re. Okay, this is me, and this is Balaya garu. Okay, what we are doing is, he is pulling that side, he is pulling this side. Who will win re? Who will win? Okay, let us see my supporters. How many of you are my supporters ra? Cheppo. Mass does not matter. Go not. Mass of the string should not be there. Mass unte, your entire experiments will be gone. You see, if there is mass, then string will eat up some amount of force. Okay, good. So you can simply say, hey, you are interested in point re, m point, ఏదైనా point తీసుకోండి. So I am considering this point re. Hey, so the tension will be always away from that point. Ante e side lo the direction of tension will be towards the left, and e side lo the direction of tension will be towards the right. Ante kada, always away from the point. Okay, similarly, when you are interested in this point ra, choose here last end of the string re. Hey, last end of the string, direction cheppu ra, direction cheppu. It has only one side re, string only on one side. Ante the tension will always be color re, color. Okay. So the tension will always be away from this point. Ekkada kuda vachi cheppandi andariki. So here also, if this is my point, cheppu, this will become my tension. Ante kada, always away from the point. Always. Yes, good. Yes. Go not. You can say that. Okay, you can say that. Okay, so the tension direction will always be away from the point. Em point ra, ఏదైనా point తీసుకోండి. Point ante mass. Gonad has said a very good answer. Okay, point ante you can simply assume it's a mass. Kani mass on the string or leda mass that is immediately attached to the string. Ante kada, very good. Away from the point. Again I am telling you. Okay, రెండు sides లో వేరే force ఉంటాయి. You can simply say the lower side force will become the tension in the string. Point number 1. Point number 2, the direction of the tension force will always be away from the point. ఏం point రా? ఏదైనా తీసుకోండి. అంతే కదా? Yes, mass. Yes, good. So if I am talking about this experiment రే, hey, చూసుకోండి. మళ్ళీ tug of war is helping us a lot రే. Okay, so thank you so much for the maker of this game రే. Okay, for making it. చూసుకో. Okay, good. So he is pulling this side, వాడు in the right side. ఇప్పుడు చెప్పండి, if I want that direction, hey, listen to my question very carefully. Listen to me. If I want direction, నాకు direction of tension కావాలిరా, on this person I want the direction of tension. Okay, on this person I want the direction of tension ra. Cheppu andariki. So sir, point ide kada? Yes. So cheppu ra, only right side string is there. So the tension will be towards the right. Ekkada vachi the same tension will become towards the left. Sir, what a cruel force it is, sir. It is changing the direction, sir. Good, very good, very good. Opposite directions, always opposite directions. So I hope you understood it. Okay, so let us do a question ra. Cheppu andariki. So let us say the block has a mass of 10 kg ra. 10 kg. Naku tension kavali ra. Cheppu. Again I am telling you, always consider the two ends. Two ends of the string ray. Hey, it is my first end ra, and here it is my second end ray. Calculate the tension. Now we are going in a reverse way ray. Hey, reverse way. Reverse way, sir. What did not understand, Nandini? Cheppu. I will tell you. What did not understand? What you did not understand? $100. Good, good. Gonad, very good, very good. 100 Newton, very good. Good, good. So tension find cheyadaniki you have to go in a reverse way. Reverse way ante enti ra? Oka block ante physics you see. Okay, you see, I will give you an example. Okay, what examples? These examples you did not understand. These examples you remember. Okay, you remember whenever we talk about tension, Nandini, the direction of the tension is always away from the point. So this is the point, away ante right side and away ante left side. Ade finished. Simple formula. Ade finished. Next, hey, you come here. You come here. I will tell you one thing. Okay, I will tell you one thing. You are walking on the road, and you find 100 rupees note. You find 100 rupees note while you are walking. Em chestaru? What will you do? Yeah. Venkateswarlu. I'll give you. Don't worry. Hey, you are walking on the road and suddenly find 100 rupees note. What will you do? Cheppu ra, cheppu. Any sincere person? Sir, we got 100 rupees, sir. Now we will have chicken biryani. Okay, we will have chicken biryani. No, sir, not chicken biryani, sir. Yes, I will take it. Yes, good. I was expecting this from you. My students, you are my students only. Okay, you will take it. All will take it, sir. Nobody will wait and watch for that person, right? Okay, yeah, go for party. 100 rupees party. Okay, good. Money in real life. Chuskondi. I am telling you the biggest secret in physics, in Newton's laws. Money in real life keeps value kada. 100 rupees are there on the road. I don't want it. I'll go. Do you think anyone will do? No, right? Money in real life keeps huge significance ra. Ade physics law mass keeps huge significance. Physics law mass keeps huge significance. Ante if it's a mass, everybody will look only at it, only at this mass. Are you understanding? Yes. Yeah, 100 rupees ki party. Yes. So sir, if it is mass ante money, mass ante M for mass, M for money, M for mass, M for money. Ante it is my money re. I got free money re. What will I do? I will leave it. No. You are my students. Okay. I am very proud of you. You said you will leave. You will take those 100 rupees and go for party. Okay. I am really proud of you, Andariki. Yes. Yeah. Kranti. I'll do it. Hey, don't worry. I'll do it. Okay. So what will you do is, you don't leave this mass kada. So in mass ni chudandi ra. Net forces. What will you do re? What will you do when you see 100 rupees note? Hey, anyone there? Anyone there? Nobody. So slowly I'll go and I'll put my leg on it. Okay? I'll slowly go and I'll put my leg on it, and then I'll see here and there someone watching. No, nobody watching, right? Nobody watching. Nobody watching. Got it. Same thing. It is money. Cheppo. Who is there in the surrounding? Who is there in the surrounding? Sir, the first person is its own weight mg ra. That means there are some claimers already. Already claimers are there for this mass. Is it moving? It's not moving. Not moving and enti. If it is not moving, that means there must be other force also. Okay? Oh my goodness. So that means there must be some other person also. Who is that person? Here. He is the person. Hey, am I audible and am I visible? Hey, give me 2 minutes, sir. Give me 2 minutes. Everything is gone from my side. Good. So that means cheppo, values cheppo, away from the point kada. Tension is always acting away from the point. Ante, sir, mg values are 10 into 10. G 10 తీసుకోండి. అంటే 100 Newton. So ఇక్కడ నుంచి tension is also equals to 100 Newton. Finished. I got it. Got it. Now come back to that property. What property? What property? What property? Hey, this property. So if remember, tension always acts opposite to the point of motion. Ante kada? We got. Okay. So you are telling that I am a thief, huh? No? That means I am a thief, Huh? Hey, I have millions. Okay, I have millions. I don't need to be a thief anymore. Okay. Good. So you come here, you got the tension. Ante kada? Ippudu properties cheptunnaru. Chuskondi andariki. Hey, properties ra. Properties of tension re. Point number 1. Very detailed properties re. You watch this lecture with huge attention, okay? You watch this lecture with huge attention. Yes, very good. Go not. Yes, we need to check people and we need to check the forces in it. Mass is your money and forces under the claimers. Okay? So you got and you place the leg, but you see one more leg is there. There is one more person who is claiming it. Understanding? Complicated matter. So property number 1 ra. If the string is massless, you remember the properties, okay? You remember the properties. I understand. Chalo. Okay. Property number 1. If the string is massless, okay? If the string is massless, each and every property can become an MCQ question for your exam, okay? Each and every property. If the string is massless, tension at each point tension at each point is same for a undivided string. Undivided ante telusa? Continuous string ra. Continuous string. For a continuous string. Cheppora. Here. We'll use this property here. Sir, నాకు టెన్షన్ వాల్యూ వచ్చింది సార్. ఎంత వచ్చిందిరా? వాట్ ఇస్ టెన్షన్ వాల్యూ 100. డైరెక్షన్ చెప్పు. అప్పర్ సైడ్ సార్. సో అంటే ఈచ్ అండ్ ఎవ్రీ పాయింట్ ఆన్ దిస్ స్ట్రింగ్ ఈచ్ అండ్ ఎవ్రీ పాయింట్ ఆన్ దిస్ స్ట్రింగ్ హ్యాస్ సేమ్ వాల్యూ ఆఫ్ టెన్షన్. అంటే 100 Newton. డైరెక్షన్ సార్ away from the points. చూసుకోండి. So here also the tension is 100 కానీ in the downward direction sir. So అంటే the force on ceiling is also 100. అంతే కదా? Good. Very good. Okay, very good. నెక్స్ట్ చూసుకోండి. A block is tied to a string and pulled from both sides with forces 10 Newton and 20 Newton. With forces 10 Newton and 20 Newton, tension in the string. Directly cheppura. Direct cheppu. I don't want to draw the figure. But direct answer cheppu. Direct answer cheppu. Not up. See the direction, okay? Here the direction is upward ra. చూసుకోండి రే, చాలా సింపుల్ కదా, ఎందుకు ఇంత కాంప్లెక్స్ చేస్తున్నారు అందరికి. Here it is up, here it is down. Opposite directions of tensions at the two ends ra. Okay, good, very good. Go nut. You don't even have to see, you don't even have to draw the diagram ra. Direct గా ఆన్సర్ రాయొచ్చు కదా సార్. రెండు సైడ్స్ లో వేరే వేరే ఫోర్సెస్ ఉన్నాయి సార్. సో ద లోవర్ సైడ్ విల్ బికమ్ టెన్షన్, అంతే. గుడ్, very good, very good, very good. So the tension is directly equals to 10 Newton. Finished ray, gone. Okay, next తీసుకోండి. Block of mass 20 kg. Hey, property number 2 రే. Hey, property number 2 రే చూసుకోండి. If two different strings are there. If two different strings are there, the tension value will be different. అంటే ఏంటిరా, అంటే ఏంటి చూసుకో. సో ఇఫ్ దిస్ ఇస్ మై బ్లాక్ రే, మాస్ ఏమరా చూసుకో రే. దిస్ ఇస్ మై ఫస్ట్ స్ట్రింగ్. I should not write the arrow ra. ఇదేనా సెకండ్ స్ట్రింగ్ రా, చూసుకోండి. Here is John Cena. Okay, I'll write a little. Okay, good. So here is John Cena. Okay, how many of you know him? ఎంత మందికి తెలుసా? And here is Brock Lesnar. రెండు స్ట్రింగ్స్ ఉన్నాయి కదా, సో వేరే వేరే టెన్షన్స్ వస్తుందిరా. ఓకే, గుడ్. సో ఇఫ్ ద టెన్షన్ ఆన్ వన్ ఎండ్ ఈజ్ T1 రా, హియర్ ద టెన్షన్ విల్ బి T2, అంతే కదా. డైరెక్షన్ రే, డైరెక్షన్ కూడా చూసుకోండి. ఓకే, గుడ్. ఓకే, గుడ్. నెక్స్ట్ క్వశ్చన్ తీసుకోండి రా. 20 kg సీలింగ్ స్ట్రింగ్, డైరెక్షన్ అండ్ వాల్యూ కావాలిరా. దిస్ ఇస్ మై సీలింగ్. సో ఇదే నా సీలింగ్ రా. సీలింగ్ అంటే చూసుకోండి రే, వి రిప్రజెంట్ ఇట్ సంథింగ్ లైక్ దిస్. సీలింగ్ అంటే హార్డ్ సర్ఫేస్. ఓకే సో ఓకే హలో. ఓకే, సో లెట్ us see here రే. ఓకే, సో ఎక్కడ వచ్చి చూసుకోండి, ఇదే మాస్ అంటే 20 kgs అంతే కదా. సో ఎక్కడ నుంచి నాకు టెన్షన్ వాల్యూ, డైరెక్షన్ కూడా కావాలి. ఎలా రావాలిరా, ఏం రావాలి, ఎలా అప్రోచ్ చేయాలి ఈ క్వశ్చన్ని సాల్వ్ చేయడానికి చెప్పండి అందరికి. గుడ్, డార్క్ అండ్ వెరీ గుడ్. ఓకే, వెరీ గుడ్. అంటే గ్రావిటేషనల్ ఫోర్స్ని చూసుకోండిరా, అండ్ టెన్షన్ ఫోర్స్ automatically opposite to the direction of gravity, అంతే కదా. ఎస్, వెరీ గుడ్. ఫినిష్ రా. mg అంటే పెట్టోరా, వాల్యూస్ పెట్టు. మాస్ 20 కదా, g is 10 కదా. సో ఆటోమేటికలీ 200 వచ్చిందిరా. కానీ డైరెక్షన్స్ గురించి కూడా కావాలి. ఏం డైరెక్షన్స్ రా? ఎస్ జోష్నా, వెరీ గుడ్. 200 is the answer. ఎస్ డైరెక్షన్ రా. ఎస్, ఈ పాయింట్ లో చూస్తే ద టెన్షన్ ఈజ్ ఇన్ ద అప్పర్ డైరెక్షన్. కానీ సీలింగ్ లో చూస్తేరా, సీలింగ్ పై యాక్ట్ చేసిన టెన్షన్ వాల్యూ డైరెక్షన్ చెప్పండి రా. సీలింగ్ ఇప్పుడు నా మేజర్ కన్సర్న్ సీలింగ్ ఓన్లీ రా. సీలింగ్ నాట్ అప్వర్డ్. ఆన్ సీలింగ్ హౌ కెన్ ఇట్ బి అప్వర్డ్ రా? ఆన్ సీలింగ్ ఇట్ విల్ బి డౌన్వర్డ్. ఏమైందిరా? సీలింగ్ ఇట్ విల్ బి డౌన్వర్డ్స్. అంటే 200 న్యూటన్ ఈ సీలింగ్ పై డౌన్వర్డ్ డైరెక్షన్ కిందకి యాక్ట్ చేస్తున్నారు. గుడ్, వెరీ గుడ్. టువర్డ్స్ ద మాస్ అంటే విచ్ మాస్? గోనట్ స్పెసిఫికేషన్స్ కావాలి. ఎస్ నెక్స్ట్ గుడ్ ఓకే. సో నా 2 blocks of mass 10 and 20 kg రా, సీలింగ్తోనే సస్పెండ్ చేసి 2 స్ట్రింగ్స్ ఉన్నాయిరా, అండ్ నాకు మొత్తం స్ట్రింగ్స్లో టెన్షన్కి వాల్యూ అండ్ డైరెక్షన్ కూడా కావాలి. ఎలా సాల్వ్ చేయాలా సార్? గుడ్, వెరీ గుడ్, అందరికీ వెరీ గుడ్. 20 kg ఓకే, చూసుకోండి రా. సో ఇదే నా సీలింగ్ రే, అంతే కదా. సో ఈ సీలింగ్తోనే ఐఎమ్ అటాచింగ్ 2 blocks రా. చూసుకోండి, ఇదే నా ఫస్ట్ బ్లాక్. ఎక్కడ వచ్చి మాస్ ఎంత ఇవ్వండి సార్? 10 kgs. కిందకి ఇదే మాస్ అంటే 20 kgs. అంతేరా, అంతే. నాకు 2 స్ట్రింగ్స్లో ఉన్న టెన్షన్ వాల్యూ కావాలి, చెప్పండి అందరికి. Hey, I'm reading it. Okay, I'm reading it. Chalo. See. So here, sir, mg and 200. Ante kada. How to do, sir? Ela solve cheyali, sir. Again, go back to that thing. Go back. Mass in physics ante money in real life. Mass ni andar chesko. Hey, you understand? You focus on mass only. How many masses are there? 2 masses. Ante this is my first mass, this is my second mass. Both masses are 2 different notes. This is 20 rupees notes, this is 10 rupees note. They are falling on the road. Nobody will go. You are my students, Ray. Okay? I'm proud of you. So, if you are not leaving that money, don't leave this mass also, Ray. Hey, cheppu andariki. So, here, ekkada vachi the tension T1. Enduku T1, T2, sir? Endukante rendu vere strings unnai kada. Chuskondi. That is the what property I have written, Ray. అరే ప్రాపర్టీ రే, 2 different strings, 2 different tensions రా, T1 T2. ఓకే, ఎక్కడ వచ్చి సార్ ఒకటే స్ట్రింగ్ కదా టిల్ దిస్ పార్ట్ రే, అంటే ఆన్ దిస్ సైడ్ టెన్షన్ విల్ బి యాక్టింగ్ ఇన్ ద డౌన్వర్డ్ డైరెక్షన్. ఓహో, అదే ఓకే. T1 అంటే హియర్ ఆల్సో టెన్షన్ ఇస్ T1 రా, పైన స్ట్రింగ్స్ వెళ్ళండి. సో హియర్ T2, ఎక్కడ కూడా T2. అదే ఇప్పుడు ఒక బ్లాక్ని తీసి రైట్ ద ఈక్వేషన్స్, రైట్ ద నెట్ ఫోర్స్ ఇస్ ఈక్వల్స్ టు 0. ఓకే, అరే నో, ఐ డోంట్ వాంట్ మనీ. ఓకే, ఐ డోంట్ వాంట్ మనీ. నా దగ్గర చాలా డబ్బులు ఉన్నాయిరా. ఓకే, in my pocket only I'm having, leave it, tomorrow income tax rate will be in my house. Okay, ఎవర్ని బ్లాక్ చేయాలా స్పందన చెప్పు. ఎవరైనా స్పామ్ చేస్తున్నారు చాట్లో? who's that? Don't spam, I'm telling you, don't spam. ఓకే, గుడ్. సో ఎక్కడ వచ్చి జస్ట్ టెల్ మీ ద ఫోర్సెస్ రే. 200 డౌన్వర్డ్, T1 అప్వర్డ్, అంతే కదా. ఎస్, 200 డౌన్వర్డ్, T1 అప్వర్డ్ అంటే సార్ బ్లాక్ ఈజ్ అట్ రెస్ట్. దాట్ మీన్స్ బోత్ ద ఫోర్సెస్ ఆర్ ఈక్వల్. అదే గుడ్. సో దాట్ మీన్స్ T1 ఈజ్ ఈక్వల్స్ టు 200 Newton. T1 కి వాల్యూ వచ్చిందిరా, ఇదే వాల్యూని తీసి 2 ఈక్వేషన్లో సబ్స్టిట్యూట్ చేసుకోండి. సో హియర్ how many claimers are there? T1 in the down, T2 in the up. Ante sir, what to do now? Are sir, T1 in the downward direction minus T2 in the upward direction is equals to 0. Ante sir, T1 is equals to T2. That means is equals to 200 Newton. Ante kada. How many of you agree with this, Ray? How many of you agree with this, Ray? It's wrong. It is wrong. Endukura? Why wrong, sir? Because you did not write the total claimers ra. mg force ఈ బ్లాక్ కోసం mg కూడా ఉంటుంది కదా, 100 Newton డౌన్వర్డ్ రా, కింద డైరెక్షన్ లో 100 Newton అంటే ఇది mg ఫోర్స్, రైట్? ఎస్. ఇప్పుడు చెప్పండి, డౌన్వర్డ్ ఫోర్స్, టోటల్ డౌన్వర్డ్ ఫోర్స్ అంటే సార్ T1 + 100. అండ్ టోటల్ అప్వర్డ్ ఫోర్స్ అంటే హౌ మచ్ రా, ఎంత T2 అంతే కదా. T1 కి వాల్యూ 100 వచ్చింది, డైరెక్ట్లీ పెట్టోరా, సబ్స్టిట్యూట్ T1 is 200 plus 100 is equals to T2 అంటే T2 is equals to 300 Newton. Good. Good. Next. Okay, next. Spring force. Chala interesting. Okay. Chala interesting ra. Before that, let me see how many people are joined. Why confused? Go nut, enduku confused? Don't keep any confusion, okay? Don't keep any confusion. What is the confusion? Cheppo, ippade cheppandi. Very interested? Yes, your brain will not brain, but my brain will brain. So that is why it is brain, your brain is not brain. So it is brain of a brain that controls the brain of the brain. Nothing ra, nothing. What will happen? Yes, Josna, very good. Just focus, Ri. Just focus, okay? T1 and T2, how are you getting confused? Ra? Directions, opposite directions. This is my point, Gonat. This is my point. Okay, tension will act away from the point, away. So, ఒకటే direction లో string ఉంటుంది కదా, so ఆ direction లో away, along the string tension will act. Here also, this is my point, Ray. So the tension will act away from the string, along the string, okay? Away from the point, along the string, right? Hurt. Spring force, ra. Spring force. Chuskondi. Spring force. Okay? That's what I'm telling you. Okay? If your brain is not braining, your brain is not brain. If your brain is braining, your brain is brain. Okay? Then tell the brain of the brain to brain properly. Good. చూసుకోండి రా, స్ప్రింగ్ ఫోర్స్ అంటే ఏంటి రా? స్ప్రింగ్ ఫోర్స్ అంటే ఏంటి? స్ప్రింగ్ ఫోర్స్ అంటే, హ్యావ్ యూ ఆల్ సీన్ ద స్ప్రింగ్? చూసారా? డిడ్ యూ సీ ద స్ప్రింగ్ రా? హౌ ఇస్ ఇట్? మేడ్ ఆఫ్ మెటల్. ఓకే సార్, ద స్ప్రింగ్ దట్ వి బ్రింగ్ 7 color spring, sir, that's not a spring. Okay, that is also a spring, but we will not use this in experimenting, ray. Shock up. Okay, shock ups of a bike, shock up of a train, shock up of a aeroplane. Krish 4 movie chusina, there is this scene in that, you know, right in the intro of the picture, the shock up of the aeroplane is damaged. So this Krish goes flying and he holds the aeroplane, something like this. He goes and holds the wheels. Good. Shock up. Spring ante shock up. Okay, spring ante shock up. Good. Spring force ante entira? So physics lo ఎప్పుడైనా స్ప్రింగ్ గురించి మాట్లాడితే you understand it is a metallic spring. Okay, so you went to market and అక్కడ నుంచి you brought a spring, ray. You do have a spring ra. Okay, so let us say this is my table. Okay sir, ఇదే నా టేబుల్. ఆ టేబుల్ పై I am putting that spring, sir. Should I draw? How should I draw? Yeah, sir, this is my table, sir. So this is my unstretched spring, ray. Symbol ide. Okay, so this is my spring, sir. Now I'm just watching that spring. I kept it and I'm just watching it, ray. I'm just watching it. Good. Length of what? Length of spring. Yes, length of spring also matters, ra. Okay, length of spring also matters. Length of spring also matters, ra. I'll explain everything. I'll explain. You just remember. So ippudu you got some okay, good. So ippudu what you're doing is you're pulling this spring and pushing it like this. You're pulling it. Ante you're increasing the length. చూసుకోండి, you are increasing the length of the spring, ante kada. Yes, actually to be honest ra, spring is a most complicated topic, most complicated. SHM lo kuda, work power energy lo kuda, your Newton's laws of motion, friction, wherever you are talking about, spring is a very complicated topic, and we don't have to go that much deep. Okay, we have to stay on the surface only re. We have to study it. చూసుకోండి అందరికి. How many students are watching re? Huh? Good. So what are you doing now, sir? We are pulling it. Pull cheste, the length is increasing. చూసుకోండి. Now you can compress also, you can elongate also. Okay, you can compress also, you can pull also. Okay, so let us imagine, hey, చూసుకోండి రా. So this is the natural length. Natural length ante enti re? You don't do anything to the spring. Leave it as it is. ఏదైనా లెంత్ తీసుకున్నారు, విల్ నేమ్ ఇట్ యాజ్ న్యాచురల్ లెంత్ ఆఫ్ ద స్ప్రింగ్, అంతే కదా. గుడ్. ఇప్పుడు వాట్ ఐఎమ్ డూయింగ్ నౌ ఇస్ ఐఎమ్ అటాచింగ్ వన్ ఎండ్ ఆఫ్ దిస్ స్ప్రింగ్ రే విత్ అ వాల్. వాల్ అటాచ్ చేసి తర్వాత వాట్ ఐఎమ్ డూయింగ్ నౌ ఇస్ ఐఎమ్ పుషింగ్ దిస్ స్ప్రింగ్ రే, నాట్ పుషింగ్, యాక్చువల్లీ పుల్లింగ్ దిస్ స్ప్రింగ్. చూసుకోండి, సో ఇదే నా స్ప్రింగ్, ఐఎమ్ పుల్లింగ్ ఇట్, ఐ వాంట్ టు పుల్ ఇట్, సో ఐఎమ్ పుల్లింగ్ ఇట్, ఐఎమ్ పుల్లింగ్ ఇట్. Length చూసుకోండి. Hey, yeah, ask what's the doubt? Absolutely, Joshna, absolutely not. In NEET it could be mixed along with simple harmonic motion, elongation, compression. It's a very important topic. It's not to ignore. Hey, spring is very important, very important topic. Okay, Nandini, let's focus on this. Okay? Let's focus on this. On the screen, I can't see the number of members who are watching. Okay? Good. So, ide na natural length, ante kada. And here, it is my total length. Chuskondi andariki. So, it is my total length L. So, what is extra length, sir? Yanta extra length ochindira. So, ide na extra length kada. Yes. So extra length enta sir? It is simply equals to L minus L naught. L is the total length, L naught is the initial length. Understanding? Good. So ee length ni I will call it as elongation and usually represent by the letter X. You remember this, okay? You remember. X ante enti ra? X ante extra length that you have obtained by pulling the spring. Okay? Joshna, if it is coming in your Newton's laws, you at least expect, in your overall physics, you at least expect 3 to 4 questions that will have spring directly or indirectly into them. Very important, chala important topics. So, this extra length ni I am calling it as elongation. Elongation ante X. Always remember, we'll name X ante elongation or compression. Okay? Leda. Same spring ni you are compressing it now re. Hey, you are compressing it now. Chappu andariki. So now what you are doing is you are compressing the spring. Compress ante this will be gone ante kada. So this is my compression. Okay, compress chesina tarvata this is my distance ra. Hey, చూసుకోండి. So this is the distance that I have got. Ante I have moved from equilibrium position. Ante kada. Yes, Gonat, yes. You remember in Newton's laws, there are 4 types of forces: spring, normal, contact and normal, right? Gravity. All four forces should be very good. Then and only then you can do something in Newton's laws. If you don't understand spring, you can't do anything. If you don't understand string, you can't do anything. Okay? You can't do anything. చూసుకోండి, here. This was my natural length. I pulled it. I made it to this level. Ante extra length L minus L naught. Ide length ni I am calling it X. X ante elongation. Ee case lo elongation. Chuskondi. L ante elongation. Okay, chuddam ra. Just be with me. Just listen to me very carefully. I'll do everything from scratch. Okay? Don't worry. Here, cheppura. This was the initial length. I pressed it. So this is my compression. How much compression ra? L naught, here let us say it is L. So cheppandi ra, compression is also x ray. Hey, x ante elongation or x ante compression, I don't care. X is simply the distance you have moved, left or right, does not matter, okay? Does not matter. Chuskondi. X ante ee scenario lo I will call it compression. What is the value of x ray? It is L naught minus L only. So elongation unte L minus L naught. Compression unte L naught minus L. Are you understanding? So this is the extra length that you moved. Left low, right low, does not matter. But you are disturbing the spring from equilibrium. Ante kada? Yes. So Hooke's law gurinchi chepte, chuskondi. Hooke's law simply says spring, hey, spring is something, okay? You move it. What will happen? Emaitidira? So when you pull this spring, release it, what will happen? Spring will come to the natural position. Ante spring will exert a force ra. Hey, spring will exert a force. Understanding? A force we are calling as spring force ra. Chuskondi. So let us say I am directly giving you a format, okay? So idena spring ra, idena mass. I am pulling this mass. I am pulling this mass and I am releasing ra. Release chase, what happens is the spring will again pull this block towards the left. Ante kada? Yes. Hey, not like this, okay? So the spring will pull the object towards itself and the natural position low. It will try to convert everything. Here also, Hooke's law, it simply says, sir, force exerted by the spring is directly proportional to x. Hey, x ante enti ra? Elongation. Leda compression. Mottam. For both. Ekkada x ante, if it is elongation, x is elongation. If it is compression, elongation or compression ra. Ante kada? Yes. So proportionality is there, sir. Sir, proportionality is there, sir. We will remove that proportionality, sir. Sir, we will remove that proportionality and then we will introduce some constant kada? Compression leda elongation, okay? Compression or elongation, does not matter. So that means you remove this alpha proportionality symbol, replace it with some constant into x. Other, what is k re? K is the spring constant. Spring constant. K is spring constant re. Hey. K is spring constant. Ante spring constant has nothing to do with you re. It will be given. It will be given to you in the question only. Okay, it will be given. You don't have to do anything. Experimental value ra. So you don't have to do it anything, it will be given to you. Spring constant guరించి మాట్లాడుతున్నా, చూసుకోండి అందరికి. Spring constant అంటే it will just tell you, I'll write it, రాస్తున్నా చూసుకోండి. So it tells about the strength of the spring. అంటే ఏంటిరా? అంటే ఏంటిరా? That means if K ante spring constant, remember, gurtpetukondira. If K ante spring constant is more, if K is more, spring is strong. Strong ante enti ra? Strong ante enti re? Strong ante enti? Resistance is high. Ante very hard spring, okay? Strong ante hard spring. It is very difficult to change the shape. It is very difficult ra. Understanding, చూసుకోండి. ఇప్పుడు K is inversely proportional to the length of the spring. L ante ఏంటి రా? L ante length of the spring. You just remember this, okay? Actually it depends upon 4 or 5 factors. I'm not going to introduce each and every one to you, okay? Okay? చెప్పండి అందరికి. Length ante the actual formula for this is very complicated, right? Can you remember? Okay, so you take the question which చెప్పోరా, విచ్ ఇస్ హార్ట్ స్ప్రింగ్ రా, విచ్ ఇస్ హార్ట్ స్ప్రింగ్ చెప్పండి అందరికి. Hey, I will be back in 5 minutes, okay? Be here only. Hey, I'm coming in 5 minutes. Hey, hi, I'm back. The villain is back into the game. Okay. So I'm here only, Ra. Okay, so చూసుకోండి రే. Hey, K is inversely proportional to length, not inversely రే. Yes, inversely. అంటే ఏంటిరా, అంటే ఏంటి అంటే గుడ్ ఈవినింగ్ ఆల్ ఆఫ్ యూ, గుడ్ ఈవినింగ్ గుడ్ ఈవినింగ్ గుడ్ ఈవినింగ్. చూసుకోండి రే, అంటే ఇఫ్ లెంత్ తక్కువ కే ఎక్కువ, లెంత్ ఎక్కువ కే తక్కువ, అంతే కదా. ఎస్, ఇట్స్ నాట్ అబౌట్ స్టిఫ్నెస్, ఇట్స్ అబౌట్ లెంత్. ఇట్ ఈస్ అబౌట్ స్టిఫ్నెస్ ఆల్సో. గుడ్. ఇఫ్ లెంత్ is less, stiffness is more. If length is more, stiffness is less. అంతే. ఓకే, ఎస్, ఏ is correct, ఏ is correct. ఎందుకంటే కే is inversely proportional at length. అంటే if length is small, if length is small, k is large. అదే, సో ఇట్ ఈస్ హార్డ్ టు మూవ్ రే, అంతే కదా. ఎస్, ఫార్ములా గుర్తుపెట్టుకోండి. ఫార్ములా ఇస్ k into x రా. x అంటే ఎలాంగేషన్, అంతే కదా. ఎస్, నౌ బ్లాక్ ఆఫ్ మాస్ 20 kg, సస్పెండెడ్, స్ప్రింగ్ కాన్స్టెంట్ 100 న్యూటన్ పర్ మీటర్. యూనిట్ కూడా గుర్తుపెట్టుకోండి, న్యూటన్ పర్ మీటర్ ఇస్ ద యూనిట్ ఆఫ్ స్ప్రింగ్ కాన్స్టెంట్. గుడ్. ఎస్, సో హియర్ ఫ్రమ్ ద సీలింగ్ రే, సో ఇదే నా సీలింగ్ రా. ఈ సీలింగ్ నుంచి దిస్ ఈస్ ద స్ప్రింగ్ రా. స్ప్రింగ్ అంటే k is equals to 100 న్యూటన్ పర్ మీటర్. ఓకే ఓకే ఓకే. వాట్ ఇస్ ద మాస్? మాస్ అంటే 20 kgs రా, 20 kgs. సో సస్పెండ్ చేసి now what happens is this spring will get elongated. Oi, 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 oi. Here, 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 here. 20 kg. చూసుకోండి, అంతే కదా. ఎలాంగేషన్ అయిందిరా. ఓకే, హౌ మచ్ ఎలాంగేషన్ సార్? నాకు తెలియదు, అదే నాకు కావాలి కదా. ఎస్ ఎస్, చెప్పండి అందరికి. సో అంటే, సో దిస్ ఈజ్ ద ఎక్స్ట్రా లెంత్, ఎలాంగేషన్ ఎక్స్. ఓ నైస్ నైస్. వాట్ ఈస్ ఫోర్స్ రే? వాట్ ఈస్ ఫోర్స్? ఫోర్స్ ఇస్ k into x, opposite direction. Okay, always remember, spring force will act in such a way that the change is nullified, right? It comes back to original state, ante kada. Yes, okay, cheppandi here. So I can simply say, sir, f is equals to k into x. Em force ra, spring force. Em direction lo ra, paina ante mg ante kinda act chestunnaru, ante kada. mg ante 200 ra, 200 is downward force. Mass ante money. You don't ignore money in physics. Okay, good. In here, spring force kx acting in the upward direction, ante these two forces should be same. It is not moving kada, it's not moving. If it is not moving, all forces are equal. Ante all ante opposite forces are equal. So you can simply say 200 is equals to k into x. Hey, k value ichina kada. Yes, so sir, 200 is equals to 100 into x. Ekkadi nunchi x is equals to 2 meters re. Good. Now తీసుకోండి రా, క్వశ్చన్ నెంబర్ 1. 10 kgs, k is equals to 100. తొందరగా చెప్పండి ఆన్సర్స్. ఐఎమ్ గివింగ్ యూ వెరీ ఈజీ క్వశ్చన్స్. ఫైన్, నాట్ 1.983. ఓకే, ఇఫ్ యూ ఆర్ టేకింగ్ g as 9.8, then it may be 1.98, but I don't know. I don't know. mg by k. సెకండ్ క్వశ్చన్ రా. Twenty kgs, k is equals to 100 Newton per meter. కంప్రెషన్ కదా, ఇక్కడ చూడండి రా. కంప్రెషన్ రే, గ్రావిటీ, mg డౌన్వర్డ్స్, కంప్రెషన్. నెక్స్ట్ థర్డ్ రా. Should I give you now, re? Should I give you now? చెప్పు, అందరికి చెప్పండి. external forces ra, external forces, last one. Hi. Idena block 10 kg re. Hi. Not this actually, I will have to remove it. Yes, good. Right. Oh, right. Combinations of spring, right? Combination and there we have two different combinations. First one is series, second one is parallel, right? Who is that? Okay, combination ante springs in series. Spring in series. దాని తర్వాత చెప్పోరా స్ప్రింగ్ ఇస్ ఇన్ ప్యారలల్స్ అంతే కదా. For now you remember the formulas only. Okay, you remember the formulas only. Good, Ritik, good. Ritik, I don't think in the last case it will be 0. No, not 0, Ritik, not 0. Okay, you see here, springs in series ante this is my first spring and ide na second spring ra. Okay, one after the another, K1, K2. Wanta sir, I want to replace this two. I don't want two springs. Hey, now go run those strings. I don't like it. Okay, I don't like it. So what I am doing now, I am replacing these springs with one single spring ra. So let us say K-net re. Hey, replace chesina tarvata. After replacing. Cheppandi andariki. Ante sir, K-net is equals to K1 K2 divided by K1 plus K2. ఎలా వచ్చింది సార్ రెసిస్టెన్సెస్ ఇన్ ప్యారలల్. గుర్తుందా? రెసిస్టెన్సెస్ ఇన్ ప్యారలల్ రా. వాట్ వాస్ ద ఫార్ములా? 1 by R net is equals to 1 by R1 plus 1 by R2. అదే ఇక్కడ కూడా సేమ్ రా. అంటే 1 by K net is equals to 1 by K1 plus 1 by K2 అంతేరా. సో రీప్లేస్ చేస్తున్నారు అంటే యూ హ్యావ్ టు అప్లై దిస్ ఫార్ములా. ఇన్ దిస్ సినారియో రా, ఈ సినారియోలో చూసుకోండి రా. సో స్ప్రింగ్స్ ఇన్ ప్యారలల్ కదా. ఎస్. సో దిస్ ఈజ్ మై ఫస్ట్ స్ప్రింగ్, దిస్ ఈజ్ మై సెకండ్ స్ప్రింగ్. K1 వాల్యూ అండ్ K2 వాల్యూ రా. I want to replace this with one single spring ray. Hey. I want to replace this with one single spring ra. Cheppandi andari. K-net. Sir, they are in parallel. So resistance is series. Ante that not R net, K-net. K2. Ante kada. I hope you understood this. Okay, combination of spring ray. Hey, question తీసుకోండి. Hey, visible, right? Hey, it's visible. Yes, sir. Find the total elongation in the following, ra. Hi. In the following, okay? In the following. First, spring K1, ra. Second, spring K2, ra. 30 Newton per meter. 60 Newton per meter. And mass is 4 kgs. Not 4 kgs, 1 kg ra. 1 kg తీసుకో. 1 kg తీసుకోండి. Next. I think I should change the color ra. Not liking the colors actually. Okay, second scenario la. తీసుకోండి అందరికి. సో ఎక్కడ the spring constant K1 is given as how much do you want it? How much do you want it? How much do you want this value, right? 200 and let us say 150. 150 Newton per meter. Let us say 50 only. Okay. 50 Newton per meter. Moodu though. Technically, I should not give these questions, okay? Technically, I should not give these questions, Ray. But because we want to practice the questions, you take it, okay? You take it. And then it will not go straight down. It will do something like this, okay? This rod will move. But I'm telling you, let us say K is equals to 100 Newton per meter. K is equals to 100 and 150 తీసుకోరా, okay? 150 తీసుకోండి. ఇక్కడ కూడా K is equals to 150 Newton per meter. ఎక్కడ వచ్చి K is equals to 600 Newton per meter. Mass is I. 10 kgs. అంతేరా, okay? Good. So you will do it or you want me to do it? చెప్పు అందరికి. You will do it or you want me to do it? Hi all, hi. Hi, Vaishali Vanam. Hi, Vaishali, hi. Three, 5. What 3-5? What 3-5? Cheppo. My legs. Good evening. Who is he? Arha. Hi, good evening, Arha. One by two. Which case, Josna, which one are you asking about? Okay, I'll do it. Okay, I'll do it. No problem. I will do it. Okay, I will do it, Ray. I will do it. Chuskondi. Here, Ray. Here. Where's it? Here. Should I copy it, Ra? Huh? Any option to copy? Lock? No lock. What is this? Move? No move. What? I don't want it to move. You see here, okay? You see here. Chuskondi. No. I want these springs, Ray. Hey, series kada? Series. Springs in series, Ray. Okay? Springs in series, Ray. Springs in series. Chappo andariki. You can simply say K net is equals to K1, K2 divided by K1 plus K2. Ante kada? Substitute cheskondi ra. 30 into 60 divided by 30 plus 60, right? Sir, how much, sir? How much? 20. 20. K ki value ochindi. Good. Ippudu take the same mass. Kani instead of these two springs, take only one single spring. Okay? Take a single spring. Ante. So instead of these two springs, take the same mass, ra. Huh? Okay? Enta mass, Ray? Okay, 1 kg. 1 kg? Hi. 1 kg only. Gone mad. Not 1 kg. It should be 0. Take 10 kgs, Ray. Okay, for simplicity. You can do it that also, but you know, values will be very small. Very small. So here 10 kg ra. Cheppo. K ante 1 kg is also fine, Ray. Yes, 1 kg is also fine. తీసుకోండి, ఏదైనా తీసుకోవచ్చురా. చెప్పు. 10 kg అంటే 100 కిందకి, అదే k into x పైనకి, అంతే కదా. సో k into x is equals to 100 సార్. x is equals to 100 divided by k is 20 అంటే 5 మీటర్స్కి ఎలాంగేషన్ వచ్చింది. తీసుకోండి రా. నెక్స్ట్ సినారియో రే, ప్యారలల్ కదా, ప్యారలల్లో ఏం చేస్తారు అంటే సింప్లీ యాడ్ ఇట్ రా, సింప్లీ యాడ్ ఇట్, సింప్లీ యాడ్ ఇట్, యూ సింప్లీ యాడ్ ఇట్ రే, యూ యాడ్ ఇట్. ఓకే ఓకే, ఎస్, యూ సింప్లీ యాడ్ ఇట్ రే. చెప్పు. $20 kg, 50, 150, అంతే. సో ఇట్ ఈస్ 50 రా, అండ్ హియర్ 150 రా. k అనేది చెప్పు రా, ప్యారలల్ కదా, k1 ప్లస్ k2 అంటే 50 ప్లస్ 100, 150, 150 అంటే 200 న్యూటన్ పర్ మీటర్ ఇస్ ద స్ప్రింగ్ కాన్స్టెంట్. ఇప్పుడు మాస్ చూసుకోండి రా, వాట్ ఈస్ మాస్? 20 kgs కదా. 20 kgs, 20 kgs, 20 kgs అంటే mg వాల్యూ ఇంతారా, mg వాల్యూ ఈజ్ ఈక్వల్స్ టు 200 mg కిందకి, kx పైనకి, బోత్ ఆర్ ఈక్వల్, ఈక్వల్, ఈక్వల్. ఓకే, ఈక్వల్, ఈక్వల్, ఈక్వల్. యా. సో నేమ్ ఇమ్రాన్. క్వశ్చన్స్ ఓన్లీ. ఓకే, క్వశ్చన్స్ ఓన్లీ. yes, questions only రే, it's questions only రా. సో k into x is equals to mg అంటే k వాల్యూ 200, x తెలియదు, mg 200, ఎక్కడ నుంచి x వాల్యూ అంటే 1 మీటర్ వచ్చింది. డన్ రే, డన్. లాస్ట్ క్వశ్చన్ చూసుకోండి, లాస్ట్ క్వశ్చన్. లాస్ట్ క్వశ్చన్ రా, దిస్ ఇస్ ద లాస్ట్ క్వశ్చన్. హియర్ దే ఆర్ ఇన్ ప్యారలల్ అండ్ దాంతోనే సీరీస్ కదా. ఎస్, చూసుకోండి. ప్యారలల్ అంటే డైరెక్ట్ యాడ్ రే. ప్యారలల్ యాడ్, ప్యారలల్ యాడ్, చెప్పు. 150, 150, 300. Here 600. Directly take the new new spring రా, చెప్పండి. సో k net is equals to k1 k2 series కదా. yes, divided by k1 plus k2 అంటే 300 into 600 divided by 300 plus 600, directly 900 రే. ఓకే, directly 900. Okay. So that means net k is equals to 0, 0 gone. 6 3s are 18 by 18 by 9 అంటే 200 Newton per meter. So it is my net k రే. మాస్ చెప్పు. మాస్ is 10 kg అంటే mg is 100, kx పైనకి, both are equal, అంతే కదా, because the block is not moving. That means kx is equals to 100, k value 200 వచ్చింది, into x is equals to 100, x is equals to 1/2 అంటే 0.5 meters, అంతే కదా. You visualize. Gonat understood, Jyoshna Reddy understood. Okay. Good. Next ray. Okay, cutting the springs. Okay. हाँ यार, हाँ, फिर से कैसा बोले, फिर से बोलने के लिए 2 घंटा लगेगा. How do you want me to tell again? Cutting the spring is there. Okay, hey, you visualize. Okay, It is the last topic. దాని తర్వాత we'll finish this with this session. అంతే కదా. Next చూసుకోండి. Okay, next చూసుకోండి రా. Okay. Cutting the spring అంటే ఏంటిరా? Imagine చేసుకో. This is the spring అంతే కదా. It is the block రే. Hey, you visualize. I'm going in a little detail రా. చూసుకోండి. You have a spring రే. Hey, how should I tell you రా? Do you have energy? Do you have interest in the class? All are sleeping only. Half left, half came, half gone. Okay. So class is also gone. Nothing left in the class also. Sir, everything gone, sir. Nothing is left, sir. Hey, చూసుకోండి రా. You apply forces F and F in left and right side. Okay. You apply. ఏమైతుంది రా? The spring will get elongated. Finished. Point number 1. The spring will get elongated. అంతే కదా. Good. So sir, the spring is elongated now. ఇప్పుడు ఏమరా? ఇప్పుడు ఏమైతుంది? Now the spring will try to come back to the original position రా. Original position అంటే ఏంటి సార్? It will exert a force. ఏం డైరెక్షన్లో రే? So from both the ends it will apply force in the opposite directions. అంతే కదా. Yes. So that means spring will apply force here and here. Are you understanding? Are you understanding? Good. So ఇక్కడ చూడండి, you have elongated this spring. So what is it doing? It is applying the force in the upper direction. ఎక్కడ కూడా it is applying the force in the downward direction. అంతే కదా. అంతే. Are you understanding? Okay, yeah, go on. Thank you so much. Chalo. So here what will happen if you cut it? Hey, I don't know how to draw scissor, okay, but you remember this is my scissor. Okay, I'm cutting this spring from upper part. Upper part tone cut chesi. What happens? What will happen if I cut it? So that means this end, చూసుకోండి అందరికి, this end, it will keep applying the force in the upper direction only. The force will not reduce. చూసుకోండి, the force will not reduce. Hey, the force will not reduce. Understanding? As soon as you cut it, this force is gone. Upper force is gone. Kani lower force is not gone. Understanding? So immediately this force will be there. It will ultimate decrease, but immediate after cutting this force will be there. Enta force sir? K into x. How much sir the value of that force? M into g. Ante kada. So that means kx force, it will be there immediately after cutting. Ante kada. Good. One last question and then session over. After that I think I had a gravitational force. We have gravitational force, we have contact force ra. Nothing is completed. Chalo, see, 10 kg block held with string from a ceiling, another 20 kg block attached to 10 kg block with the help of a spring. If the spring is cut from 10 kg side, immediately after find the tension in the string and acceleration of all blocks ra. Chuskondi. So ide na ceiling. A ceiling nunchi I am directly attaching a block of mass 10 kg ante kada. Yes. So with this block now I am attaching a block of mass 20 kgs. Good. Hey, cheppandi ra. Values cheppandi. Tension in the string how much re? How much tension in the string re? If you cut this string, okay? If you cut this string, both the masses will move down. Ante this string is supporting both the system. Chuskondi. Mottam system is supported by the string. So T is equals to total mass into G. Ante 20 plus 10 ante 30 kg. 30 into G is how much? 300. Ante tension is equals to 300. Ante kada? Yes. Elongation gurinchi cheppura. How much elongation? Cheppandi andariki. So elongation is, sir, mg is 200. Ekkada. Force is k into x. K value how much? 100. So that means 100 into x is equals to 200 ante x value is 2 meters. These are my initial conditions ra. Okay, initial conditions ante enti re? Initial conditions ante initially the elongation is 2 meters, initially tension is 300 meters ante kada. Yes, eppudu you are cutting the string re, you are cutting the spring, chuskondi andariki. Now you are cutting this spring from 10 kg side ante you are cutting this spring from this side ra. So this is the cutting point. This is the cutting point. Cut chesina tarvata what happens immediately? Cheppandi. Immediately the force that was acting here, it becomes zero. Gone. Ante system will look something like this. So this is my 10 kg block and immediately the spring has been cut. Ante kada? Yes. 20 kgs. But remember what I said? Only one side force will be gone. Force is gone. Ante the spring will try to come down. But this end is again applying the force. This force will not be gone. It has not been cut. It is there in the contact. Okay. So acceleration of 10 kg block is 0. Point number 1. It has been supported by the string. Can its tension value, it will maripoindi. Okay. So you can simply say that tension is equals to 100. It is only supporting 10 kg block now. ఇప్పుడు వచ్చి చెప్పండి యాక్సిలరేషన్ ఆఫ్ 20 kg బ్లాక్ ఇది కూడా జీరో రా. ఇది కూడా జీరో. ఎందుకంటే mg is acting in the downward direction 200, but the spring force is also acting 100 into x చూసుకోండి, అంటే spring force is also 200. So that means the acceleration of this 20 kg will also become zero. But ఒక బట్ ఉంటుందిరా చూసుకోండి. But it will only be valid immediately after cutting. If you are waiting for some times up, కొంచెం సమయం let's wait అంటే situations will change రా. It will fall down also. Okay, it will also fall down. అంతే. So accelerations of both the blocks are zero. కానీ tension value has changed. Okay, it was there 300, now it is only 100. అంతే కదా. Yes. Okay, good night. Bye. Good. So if you don't have any doubts, can we terminate this session ra? Cheppandi andariki. Any doubts? Yeah. Soumya, thank you so much. Bye andariki. Bye. No, go not. No. Acceleration of 20 kg block will be zero again. Endukante the force has not been decreased. Spring is pulling from both sides. 20 kg also, 10 kg also. You cut this side only. So this side force will be gone, but this side force will be present immediately after cutting. Ante this force is there, this force is there, balanced. Ante acceleration will be zero. Okay, good. Very good. Go not. Very good. You got 105 in circular motion. That's a huge achievement. Okay. Good night, Parimala. Good night. Cutting from here. Bhanu, cutting from this side. Until this side force becomes zero. Not here. This side force remains as it is. Okay. Thank you so much, Joshna. Thank you so much for this motivational message. You know, such messages keep me alive and kicking. చెప్పండి అందరికి. గుడ్ నైట్. Good night. Good night, sweet dreams. Good night. Bye అందరికి. Bye all of you. Bye. Thank you so much. Good night, Maitri. Good night. Thank you so much, Geetanjali. Thank you so much. Yeah, Maitri, sure. Good night. Good night. Good night, Andariki. Good night. Yes, go not tomorrow also NLM. ఇప్పటి నుంచి for 4 days or 4 to 5 days till New Year రా, till New Year Newton's laws only. Newton's laws అంటే ఫస్ట్ లా, దాని తర్వాత సెకండ్ లా, అండ్ దెన్ థర్డ్ లా, application based, mixing of the laws, and then question solving. అదే then our session will be completed on Newton's laws. Yes. Thank you so much. Yes, thank you so much. Okay, that means something. It means a lot actually. Chalo, good night all of you. Good night. Hi, your friend. Hi. Thank you so much, Parimala. Chalo, good night all of you. Good night. I'll take a leave now and let's meet tomorrow at the same time, 6 p.m. Tomorrow is Sunday, right? Tomorrow is Sunday, so Sunday will be 5 p.m. Okay, Sunday 5 p.m. Sunday 5 p.m.